a decimal number, see, division of a decimal number by 10, 100 and 1000. So this division of a decimal number by 10, 100, 1000 or 10 powers or multiples of 10. If you divide any decimal number by the multiples of 10, what will happen? That now we are going to discuss. See, if we divide a decimal number by 10 or 100, 10,000, sorry, 1000, 10,000, so on, then the decimal point in the product shifts to the left by as many as zeros in 10, 100, 1000. So let me discuss one concept. For example, 132.7 by 10 is there. That means if you divide 132.7 by 10, what will happen? So according to this concept, decimal point in the product shifts to left by as many as zeros in 10 or 100 or 1000 or like so on. For example, in 10, how many zeros are there? 1 0. So now we need to shift this decimal point to the one place, to the left. Left means this side, this direction. So this becomes 13.27. 13.27. I hope it's very clear. Suppose, for example, if you divide 17.36 by 100. So now what will happen? In 100, how many zeros are there? 2 zeros. So this point should be shifted to the left side for 2 places. 2 places means already we have 2 places here. 1, 2. Here, this point will be shifted to here now. So that's why this becomes 0.1736. I hope it's very clear to you. So now we are going to discuss next concept, that is the rational numbers. What do you mean by a rational number? So rational numbers are a bigger collection of numbers which includes integers, positive fractional numbers and all negative fractional numbers. So integers means integers will include natural numbers and whole numbers also. So besides positive fractional numbers, negative fractional numbers, then that is called a rational number. What do you mean by rational number? Rational numbers means rational number. Rational number means here integers plus positive fractional numbers plus negative fractional numbers. Union, generally we write mathematically union. Union of all these gives us the rational number. In general, the rational number will be in the form of P by Q, where P is an integer, Q is also an integer. P by Q form. And also moreover, Q does not equal to 0. So that means the numbers in the form of P by Q, where P and Q are integers, Q does not equal to 0 are called rational numbers. Now we can write like this. Rational numbers are denoted by the letter Q. Q is equal to X such that, we need to read such that X is equal to P by Q. Here Q does not equal to 0 and we need to define this one also. P and Q are integers. So this is called actually rational numbers. Rational numbers will be in the form of P by Q. In rational numbers, we have integers, positive fractional numbers and negative fractional numbers. Including all these three, which is in the form of P by Q, if you are able to put in the form of P by Q, then that is said to be the rational number. I hope it's very clear. And one more very important property the rational numbers will follow. This A into B plus C is equal to AB plus AC. This property is called distributive law of multiplication over addition. So that means, my dear students, you remember one thing. Suppose if you want to find this value, A multiplied by B plus C. See, where A comma B comma C are rational numbers. Generally, our rational numbers means we can write belongs to symbol. This symbol, please remember how to read this symbol is belongs to. Belongs to. So A comma B comma C belongs to the collection of Q or set of Q also rational numbers. Then A into B plus C means how to multiply means A into B. Next A into C also we need to write. That means we get A into B. What is the symbol here? We have plus. Next A into C. Then A into B is AB plus AC. This property is called distributive property. Distributive property. Distributive law also we can say distributive. Multiplication is distributive over addition. Over addition. Clear? Right. So one more thing. So let us move to the next page, the previous page once again. Even distributive law of multiplication over subtraction also, it is distributive. If A comma B comma C are, see next page, A times B minus C is there. In the similar fashion, A into B AB, A into C AC. You can write AB minus AC. That means distributive over subtraction also. If A comma B comma C are rational numbers. So next, let us discuss the properties of the rational numbers. See, properties of the rational numbers, very, very important. It is stretch. In a table, we can discuss all the properties. Addition properties, subtraction properties, multiplication properties, division properties. Generally, addition, subtraction, multiplication, division are called four fundamental operations. So called an operation. So there are operators, symbols for the operators. So first closure property, addition. With respect to addition, it is closure property satisfies. Commutative property, with respect to addition satisfies. Associative satisfies. Identity, yes, identity we have the 0 is there. Identity element. Inverse. For example, A is a rational number minus A is a inverse. A and minus A are called inverse one another. So that means minus A exists. So that means with respect to addition, rational numbers are satisfies closure property, commutative property, associative property, identity property, and inverse property. Clear? With respect to subtraction, closure, but it's not commutative, it's not associative. With respect to subtraction, no identity, no inverse. Only it follows only one property, that is closure. Now, with respect to multiplication, closure. So, with respect to multiplication, commutative. With respect to multiplication, associative. Identity, except to 0. 0 means actually already we have the 0 is identity. So here not like this, actually here I don't. Inverse, except 0. Except 0. 0 should be here. For 0 there is no inverse. Inverse means, for example, if A is a rational number, its inverse is 1 by A, or we can say that multiplicate inverse, or we can say reciprocal also. If A is equal to 0, what does it become? 1 by 0. 1 by 0 is not defined. Not defined. That's why except 0, for all rational numbers, the inverse exists. In division, closure, but except 0 for 0. Not commutative, not associative, and these two will not hold good. Clear? So, rational numbers will follow. With respect to addition, all the properties will follow. With the subtraction, only closure. Multiplication, all the properties will follow. Only one condition, for except 0 element. Right. So now you see important points. Rational numbers except 0 satisfies inverse property under multiplication. This is very important. If a comma b are any two rational numbers, then a plus b by 2 is a rational number between them. For example, a comma b are two rational numbers, belongs to the rational numbers. In between them, there exists a one number in between them, that is a plus b by 2. A plus b by 2 is a rational number, always lies between a and b. This a plus b by 2 is also known as mean of a comma b. Mean of a comma b, or arithmetic mean of the two numbers a and b, where a and b are the two rational numbers. Arithmetic mean of a and b lies between a comma b itself only. So now one more question will arise. This very important concept also. How many rational numbers can we insert between any two rational numbers? For example, a one rational number, b. In between them, how many rational numbers we can insert? That means infinite rational numbers between any two rational numbers. This property, beautiful property, is called density property. So next, every rational number can be represented in a decimal form. So for example, I will come to one point. For example, 1 by 2 is a rational number. This 1 by 2 or 1 by 3, something 2 by 3, 2 by 5, so something 7 by 5. They can express in decimal form also. 1 by 2, 0 point form you can write, 0, 0.5. This is 0.3333 and so on. This can be written 0.666 and so on. This is 0.4, you can write it if you divide. So this we can 7 divided by 5. You see 5 1 ja 5. 2. 2 cannot be divisible by 5. Put the point and 0. 5 4 ja 20. So that means this can be written 1.4. So that means all the rational numbers can be put in the form of the decimal expansion form. They are called decimal expansion. Decimal expansion you can write in rational number p by q form also. Vice versa. Okay? Like this. So now you see decimal. Hello. I think I am audible to you. So rational numbers can be represented as terminating decimal and non-terminating but recurring repeating decimals. Right. Okay. Next point. Terminating decimals. So just already we have discussed the examples. The number of digits in decimal part are finite. Those are called terminating decimals. For example, 1 by 2 is there. The 1 by 2 we can write 0.5. For example, 1 by 4 is there. This we can write 0.25. See, here decimal, actually 0.5 means decimal part. This point after decimal symbol, point after, they are said to be the decimal part. Decimal part are finite. Finite means countable numbers. Only one here. Point after two numbers. These two are said to be terminating decimals. Terminating decimals. See, for example, 1 by 2, 3 by 8, 13 by 25. Otherwise, if the denominators are in the form of 2 to the power of m or 5 to the power of n, or both 2 to the power of n into 5 to the power of n, then they are terminating decimal. Very simple test. Given rational number is a terminating decimal or not, with the help of this we can check. just look for the denominator. If the denominator is 2 to the power of m or 5 to the power of n or both 2 to the power of n in m into 5 to the power of n form, then they are terminating decimals. Okay. Right. See, these properties are very, very important. Without properties, actually, the number system, the properties are very, very important. I am going through the even your comment sections also. The property, without properties, actually, we cannot go further. That's very important. Right. Next, non-terminating recurring decimals. See, for example, 1 by 3 is there. This 1 by 3, we can write 0.3333 and so on, we can write. Simply, shortly, we can write 0.3 bar, we can write it. Similarly, 5 by 3 is there, that we can write 1.666, so on. This we can write 1.6 bar. These, the set of digits which repeats in a non-terminating recurring decimal is called period. Number of digits in a period is called periodicity. The number of digits in a period is called periodicity. So that means actually, you see, it's very important. What is period and what is the periodicity? Let's have a discussion here. For example, 0.1275. Actually, this means 0.12757575 and so on. This is actually non-terminating recurring decimal. So in this one, actually, the 75 is called period. 75 is called period. So here in 75, how many digits are there? 2 digits. So its periodicity is 2. For example, like this is there, 0.1375 bar is there. This means 0.1375, 375, 375 and so on. Now tell me, what is the period? Here period is equal to 375. What is the periodicity? Periodicity is 3 because 1, 2, 3. Clear? This is very important. This is very, very important. Okay. Right. Very good, Nana. Very good. Very good. Vigneshwari, Kiran, Manideep. Very good. Very good. Everybody is following. Wonderful. Wonderful. Right. So let us move to the next one now. This is very important concept. Tomorrow we shall discuss the problems. Before that, we need to discuss, this is very important. Square roots and cube roots. This is very important. That means here we have the squares also, cubes also. The squares, cubes, square roots, cube roots are very, very important for mathematics, for very, very, very important for even, it will be very, very useful for even your mental ability classes also, math section also. So that means it will be useful for reasoning class also. That's why you need to concentrate more, because you are asking why should we study about the properties of a number and square numbers, means it will be useful for all or other applications also. Right. Let's have a discussion first of all. Here, see the square of a number and square numbers. The square of a number is that number raised to the power 2. For example, you take any number. This, how to read this one? 3 square or 3 raised to 2. How to read this one? 5 square or 5 raised to 2. Here, for example, 3 square is there. 3 is called base. 2 is called exponent or index. You called index. So this total 3 square is called power. 5 square is called power. Clear? For example, here a square. What is the meaning of a square? A square means a into a. A square means a into a. So that is the square of a number is obtained by multiplying itself. So that means how do you get square of a number? For example, if you want to find out 3 square, so it should be obtained by multiplying 3 itself only. 3 into 3. How do you get the 5 square value? 5 into 5. How do you get 6 square value? 6 into 6. So 3 into 3 is 9. 5 into 5 is 25. 6 into 6 is 36. I hope it's very clear. So next, perfect square. A natural number n is called a perfect square if there exists a natural number m such that n is equal to m square. So that means, for example, you take 1. 1 we can write 1 square. So this one is called a perfect square. 4. This 4 we can write 2 square. So 4 is called a perfect square. So next you take 9. 9 we can write 3 square. 16 we can write 4 square. So next 25 you can write 5 square. Next 36 you can write 6 square. 49 you can write 7 square. Next 64 is 8 square. I hope you will be getting 81 is 9 square. 100 is what? 10 square. So that's why 1 comma 4 comma 9 comma 16 comma 25 comma 36 comma 49 64 81 100 and so on called perfect squares. Perfect squares are square numbers. Square numbers. I hope clear. This is 1 square. This is 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, 10 square, and so on. So, my dear students, I give one suggestion to you. Better remember 1 square to up to 30 square values, you need to by heart it. By heart means don't by heart it, you practice. 1 square value, 2 square value, 3 square value, up to at least 30 square, even sometimes if possible 40 square also you must remember. I hope it's very clear to you. Right. Next, see square root. What is the square root? Simply the square root of a number A is that number which when multiplied by itself gives as A as the product. For example, see, suppose A is equal to B square. A is equal to B square means B is square root of A. Suppose I will write one more thing. See, 9 is equal to 3 square. Now, this 3 is the square root of 9. Symbol for square root is this one. Symbol for square root. That means you can write like this. Square root of 9 is equal to 3. Even square root of 1 is equal to 1. Square root of 4 is equal to 2. Square root of 16 is equal to 4. Tell me square root of 49. Sorry, 49 is 7. So always remember square root of any number is, for example, square root of 4 is always positive number only consider. Don't write plus or minus. Only this is called prime value, prime square root. That is said to be prime square root. Positive you need to take it. And one more thing you must remember, my dear students. Important properties of square numbers. Please try to concentrate this one. This is very, very, very important. Very, very, very important. Because the problems based on this one will be given in the NMMS examination or any entrance exam. Not only NMMS, it will be useful for you throughout your life also. See, perfect squares does not end with 2, 3, 7, 8. You always remember, square of any number does not end with the digits 2, 3, 7, 8. For example, unit digit is 2, 3, 7 or 8. It is not at all a perfect square. Because sometimes a question may be asked. Of the following is not a perfect square. Is not a perfect square means just check the unit digit. If the unit digit is 2, 3, 7 or 8, then it is not a perfect square. That means 152, end with 2. 7693, end with 3. 14357, end with 7. They are not perfect square. And one more important thing you remember, Nana, the number of zeros at the end of a perfect square is always even. Always even. For example, if you square any zero is there, for example, 10 square is there. 10 square means you get 100. See, now you count how many number of zeros are there? 2. 2 is an even number. For example, 100 square. 100 into 100. 1, 0, 0, 0. You count the zeros here. 1, 2, 3, 4. 4 zeros. So that means the number of zeros at the end of a perfect square is always even. The squares of even numbers are always even. Squares of odd numbers is always odd. So this is very important. Square of any even number is always a even number. For example, 2 square, 4, even number. 4 square, 16, it is divisible by 2, is even number. 8 square, 64, even number. 10 square, 100, even number. Square of an even number is always even. Yes or no? You need to chart. You need to chart. Yes or no? Yes or no? Very good, very good. Tanusri. Yes, very good, very good, very good. Very good, very good. Don't chart separately, just discuss with us. Right, very good, Nana. Very good, very good. Right. So now one more important point need to be discussed here. This is very important. Even you can take the screenshot also, no problem. For example, in the given number, unit digit of a number is 0. In a square number, unit digit will be 0. Unit digit in the number is 1 or 9. In the unit digit of square number will be 1. For example, in the unit digit 2 or 8, you will be getting 4. In the unit digit in the given number is 3 or 7, you will be getting end with 9. 4 or 6, 4. 5 is always 5 only, very simple. 5 is always 5, end with 5 itself. So next, a number contains n digits, then square contains 2n or 2n minus 1 digits. Every natural number, one more thing, n plus 1 whole square minus n square is equal to n plus 1. The difference of squares of two consecutive numbers, this is highlight. This is very important point. See, the difference of squares of two consecutive numbers is the sum of the numbers. Is the sum of the numbers. So, if the difference of the squares of two consecutive numbers is sum of the numbers, I will tell you. For example, 2023 square minus 2022 square, you are asked. You need not find out 2023 whole square and 2022 whole square. Simply add these two numbers, 2023 plus 2022. Answer will be 4045. That's all. I'll give one question to you. You try to solve it. 5047 whole square minus 5046 whole square. What is your answer? I'll check your chart section. Chart section. Akanksha, try to concentrate on the lesson itself. What is your answer now? What's your answer? This 5047 and 5046 are consecutive. Consecutive means this 5047 is the successor of 5046. Right. Wonderful, Nana Harika. Wonderful, wonderful. Good job. That means 5047 plus 5046. Right. 5047 plus 5046. Adding. What do you get now? Yes, 1390. So 10,093. Wonderful, wonderful, wonderful job. Yes, Banala Ramyasri. Very good. Pranati, Srinidhi. Good job, good job. Very good, very good, very good, very good. Okay, let us move to one more. Right. Next concept, let us have a discussion on next concept. Right. Right. See, already we had a discussion this one. 1 minute. I will come back. See. See, there are 2n non-perfect square numbers between two consecutive square numbers. This is very, very important. You have asked one question. For example, two consecutive square numbers, that means n square, n after n plus 1, n plus 1 square. In between these two values, how many non-perfect square numbers? That means you take n and multiply with 2. 2n you will be getting. So I will ask you one question to you. How many non-perfect square numbers between like this 5 square and 11 square? Sorry, 5 square, 6 square. 5 after 6 only, 5 plus 1, 6. Simply here, this is in the form of n square. This is in the form of n plus 1 square. So number of non-perfect squares is equal to, we have the formula. What is the formula? 2n. That means here from this one, n is equal to 5. So 2 into 5, there will be 10 non-perfect square numbers. So now I will give one question to you. Try to solve it. So the number of non-perfect square numbers between 25 square and 26 square is: first option 26, second option 52, third option is 49, fourth option is 50. What is the correct option? At least I need more than 70 answers. Very good, very good, very good. Pranati. Check Pranati. Nandini, absolutely correct. Yes, very good, very good, very good. Archana, Muddamu, Archana. Yes, Netra, Vigneshwari, Hemasri. Oh, very good, Nana. Wonderful, Nana. Understood. I hope everybody understood. Right. You see the hint. This 25 square is equated to n square. 26 square is n plus 1 square. So from this we get the n value. N value is equal to 25. We need number of non-perfect squares. So number of non-perfect squares is equal to 2n. 2 into 25 is equal to 50. Only 21. Madhusalini, what's your answer? What's your answer? Akshit. Very good, Arajya. Sashikiran. Very good, very good, very good, very good. I'll give one more question also. Don't worry. Right. The number of non-perfect squares. Are you ready? Non-perfect squares between 225 square and 226 square is A 226, B 425, C 450, D 452. Okay, what's your answer? What is your answer? Very good, very good, very good, very good. Everybody understand. Nishant. Okay, okay, MS3. Wonderful, Nana. Wonderful job. Wonderful job. You did a wonderful job. Yes. See, very simple. This is n square. You can write n is equal to 225. Number of non-perfect square numbers is equal to n. 2 into 225. That is 450. Yes. C is the right answer. C is the right answer. Right, right, right. Very good, very good. Right. So let us move to next concept. Next concept. This is also very interesting. Very interesting. The square of a natural number n is equal to sum of the first n odd natural numbers. The square of natural number n is equal to the sum of the first n odd natural numbers. How do you understand this concept? This is very important. So how do you understand this concept? The square of a natural number n is equal to the sum of the first n odd natural numbers. So I will explain in a simple manner to you. Don't worry. For example, you see, 1 square is there. 1. Next odd number is 3 square. So, sorry, any number. Square of any number. Square of any number. Square of any number. Okay. Let me write. So 2 square. 2 square is equal to 1 plus 3. Sum of the first two odd we can write. So 3 square. 3 square means 1 plus 3 plus 5. See. 4 square. 4 square means you can write 1 plus 3 plus 5 plus add 2 for you will find a pattern. 1 plus 2 3, 3 plus 2 5, 5 plus 2 7. 5 square. How do you write 5 square? Tell me. 1 plus 3 plus 5 plus 7 plus next odd number is 9. Similarly, I will use 6 square, 7 square, 8 square, 9 square. Express these four values as this pattern. Extend this pattern. Clear? That means express 6 square as the sum of the odd numbers. 7 square also express as the sum of the odd numbers. 8 square, 9 square. I will see your answers. I will see your answers. I will check your answers. I will check your answers. Very good, very good, very good. Right, very good, wonderful, wonderful. Rashmita, Muddam Archana. Yes, everybody. Right, right, right. Okay. So that means we will get some idea also. 1 is equal to 1 square, you can write. 1 plus 3 is equal to, you count to how many odd numbers? 2. So 2 square you can write. 1 plus 3 plus 5. This is 3. 3 square you can write. Suppose if is given like this, all are odd numbers. 1 plus 3, 5. 3 plus 5 plus n. N is a odd number. You will write n square. This is the formula. It's called formulation also. 1 plus 3 plus 5 plus n. N is a odd number. You will get n square. Clear? I hope it's very clear to you. Right. Next concept. Let us discuss next concept. See, this is very important. Pythagorean triplets. A triplet A comma B comma C of three natural numbers is called a Pythagorean triplet if A square plus B square is equal to C square. So when do we say that A comma B comma C is a Pythagorean triplet? Triplet means three. Don't get confusion. Okay, better. GS, better. Okay. Now, the triplet A comma B comma C of three natural numbers called Pythagorean triplet. A square plus B square is equal to C square. See, for example, 3 comma 4 comma 5, 5 comma 12 comma 13, 8 comma 15 comma 17, 7 comma 24 comma 25 are example for the Pythagorean triplet. There are many Pythagorean triplet we can find out. Generally, we have 3 comma 4 comma 5, 5 comma 12 comma 13, 8 comma 15 comma 17, and like that. They are the Pythagorean triplets. Akshit Madhavi, right. Right. See, let us check now. 3 comma 4 comma 5. 3 comma 4 comma 5 is a Pythagorean triplet or not? We need to check. How to check means how to check. How to check. This is the question mark for us. How to check means find 3 square plus 4 square. 3 square you know 9, 4 square 16, 25. Now take 5. So 5 square find out 25. So that means 3 square plus 4 square is equal to we get 5 square. It's a beautiful theorem. This is called Pythagorean theorem also. They said to be Pythagorean triplet, and Indian mathematician Bauddhayana also contributed to prove Pythagoras theorem. Clear? So yes, this is a Pythagorean triplet. Now, for example, if you move to 5 comma 12 comma 13, let us check whether it is a Pythagorean triplet or not. Whether it is a Pythagorean triplet or not. Check this one. 5 square plus 12 square. 5 square is equal to 25. 12 square is 144. So 144 plus 25 is 169. Now 13 square. 13 square is equal to 169. Yes, this is a Pythagorean triplet. Like that, you check 88 comma 15 comma 17, 7 comma 24 comma 25. Is there any general formula? Yes, general formula means 2n comma n square minus 1, n square plus 1. Here n greater than or equal to 2, you take it now. So n greater than or equal to 2, you put n is equal to 2, n is equal to 3, n is equal to 4. You get the Pythagorean triplet, you can generate it. This is called generator. Generator of the Pythagorean triplets. As many as can be generated. So tomorrow we are going to discuss how to generate the Pythagorean triplets also. Thank you. Bye bye. Have a nice day.